Alright, so this is our second of two videos on game theory. If you didn't watch the first, just go back, scroll up in the playlist, and check that out, because the terminology discussed in that video is important. So for this video, we're going to study the Prisoner's Dilemma, which is a famous game, and just to give a little backstory on what it's meant to represent, the idea is player 1 and player 2 have committed a crime together, and now the sheriff has arrested them. He doesn't have hard evidence that either of them are guilty, but he offers each of them a deal. If they're the first person to confess to committing the crime, that the two of them committed it together, and testify against their co-conspirator, then they won't have to serve as much prison time, so they'll kind of get off lightly. The catch is, if neither of them decides to make the deal, then they both only get like a really light sentence, like a slap on the wrist or serve 1 month or something. So actually it turns out that if we wanted to maximize the total payoff to the two of them, the best sell to be in here would be that both of them don't make a deal, right? They both get a payoff of 3 each, which is better than 4-1, 1-4, or 2-2 if you sum up the payoffs. All right. So what we want to do now is consider the best responses for each of the players. And as we find these best responses, we're going to be reviewing some of the terminology. So to find the best response for player 1, we know that he picks between his two strategies. He can make a deal or not make a deal. And he's going to have a best response to when player 2 makes a deal. So that means he's stuck in this column. And he looks and says, if I make a deal, I get a payoff of 2. If I don't make a deal, I get a payoff of 1. So his best response is the one with the higher payoff, the higher number here, which is a deal, which gives him 2. We repeat the same exercise. If player 2 doesn't make a deal, so we're in this column, then he can either make a deal and get a payoff of 4, or not make a deal and get a payoff of 3. And it's pretty clear that, by definition, since 4 is bigger than 3, he's better off with making a deal. And what we notice here is that regardless of what player 2 does, player 1's best response is to make a deal. If player 2 makes a deal, I want to make a deal and get 2 instead of 1. If player 2 doesn't make a deal, I want to make a deal and get 4 instead of 3. So we call that a dominant strategy. So player 1 has a dominant strategy. Dominant strategy. And that's a term that you should know. It's something we see here that both players, it turns out, will have in the Prisoner's Dilemma. Occasionally, players will have it in other games. Although I think in real life, in lots of games economists study, the dominant strategies are pretty rare. Typically, the best response you have is going to depend on what the other person does. If the other person kicks to the left, you might want to block to the left. If he kicks to the right, you want to block to the right. If he advances his pawns forward, you might want to make defensive chess maneuvers. If he's very defensive, you might want to, choose a different strategy, maybe be more aggressive or something like that. All right. So now let's go ahead and find the best responses for player 2. I kind of already revealed that he has a dominant strategy, and probably not too shocking that since he basically has the same choices as player 1, that dominant strategy is to make a deal. But let's go ahead and see that out. If player 1 is making a deal, then player 2 can either get 2 from making a deal or 1 from not making a deal. Clearly he's better off making the deal. And similarly, if player 1 doesn't make a deal, then player 2 can make a deal and get 4, or not make a deal and get 3. So once again, he wants to make the deal. So now that we've underlined all of our best responses, we can see another term that's really important. We call any situation where everyone is playing a best response. And since best responses are underlined, that really means any situation where all the numbers are underlined, like in this box right here, we call that a Nash Equilibrium. So Nash Equilibrium means everyone is doing a best response, or as I like to put it, we have mutual best responses. In this game, there's a single Nash Equilibrium. None of the other boxes has both numbers underlined. But in general, games could have 1 or 2 or no Nash equilibria as far as we're concerned. And if you're wondering, this Nash is the same. This is named after John Nash from A Beautiful Mind fame. So to review, we looked at the Prisoner's Dilemma. This is a game you should know. We underlined all the best responses. We saw that both player 1 and player 2 have a dominant strategy, meaning they always have the same best response. In this case, it was deal for both of them. And then we circled the Nash equilibrium for this game. A Nash equilibrium is defined as mutual best responses, and in terms of looking at the chart, that means that all the numbers are underlined so that, everyone's playing a best response. Both of these terms, dominant strategy and Nash equilibrium, is important, and probably the most important thing is being able to underline the best responses in order to find those Nash equilibria and dominant strategies. So make sure you do some of the practice problems in the book and on the website and on the problem set so that you can be confident you can identify Nash equilibria.